All right. Hello, geometry students. I got with me Mr. Lewis. I'm Mr. Miller. Guess what it's time for?
Looks like the distance formula.
Yep, again. It's very important. So this is video number 62. Get ready. So first we want to talk about where the distance formula comes from. So here we have 2 points in the plane. We're given their coordinates, but we don't have any squares to count. Like before, when we have the grid, we can count squares to figure out what the rise and run are and compute the distance.
Yeah.
But here we just got to go with the coordinates. So Mr. Lewis, why don't you find the coordinates of that third corner of the triangle?
Well, this would take the x2 of 15 and the y1 of 7.
Okay. And the reason why we want to do that is because now we can find the length of the legs of the triangle.
Right.
So
we have 15 minus 3
yep,
gives us 12.
That
So
would be
that
the
would
bottom
be
leg.
this guy.
The difference in x's.
Mm-hmm.
And
And then,
then
we have 12 minus 7, 5. That would be this guy.
Okay.
And now we can use the Pythagorean theorem.
You got it. That's the plan.
5 squared plus 12 squared equals c squared.
Okay. That is 169.
Yeah, because it's going to be 13.
Yeah, 5, 12, 13 triangle.
Yeah.
We'll talk about Pythagorean triples later. There's a way Mr. Lewis knew that so fast.
Take the square root, and yes, 13 is our winning side.
That's the distance between those 2 points.
Mm-hmm.
Now, it's kind of nice when it works out to a whole number. So usually we're going to get a decimal or a square root or something.
Yeah.
All right. Now, we're going to go for it. We want to explain in general where the formula comes from. So here's the same kind of diagram, but this time the points are just labeled x1, y1, and x2, y2.
Yeah. Well, we still, as we saw before, we used our x2 as our point here.
Right.
Okay, because we moved over, and then we haven't gone up, so we still use our y1 right there.
Cool.
Mm-hmm.
All right. And then we can just subtract.
Right. So we had x2 minus x1, and then we had y2 minus y1.
Right. So x2 minus x1, that's like the run. That's the change in x. That's the length of the bottom leg.
Mm-hmm.
y2 minus y1 is the length of the vertical leg.
So b for bottom, v for vertical.
Okay. So now we have to square them.
Yes.
Do the Pythagorean
So
theorem.
we square this result squared plus y2 minus y1 squared, and I'm writing at an angle, equals whatever that side squared is.
Right. Or c is, why don't we label c? C is the hypotenuse.
Yeah.
And that's the distance we're trying to find. And so if you take the square root,
Yeah. To get 1c, we take the square root, so that means we're taking the square root of this whole thing.
it's kind of annoying to write. But after like using it enough times, you eventually kind of remember it. So just by
Yeah.
practicing, you know,
Yeah.
you'll have that memorized. All right, very good for the ACT, other test. All right, so that's where it came from. It's just Pythagorean theorem. Now we're going to use it. So, thank you.
No
All
problem.
right, so we're going to just practice plugging in points in the distance formula. It's kind of very mechanical.
Okay.
So at first, why don't we label the points? Just this once. That's x1,
So this is x1, y1,
y1,
x2, y2.
and just like slope. Remember the little ones and twos? They're not exponents, they're subscripts.
Right.
They just refer to what point they came from.
Exactly.
Okay, so here we go. You do the second x coordinate minus the first one.
Okay. So 22 minus 7 squared plus 20 minus 12 squared. But the answer is going to be 17.
Oh man, I didn't have a chance here. I'm sitting here fumbling with the calculator. Well, yeah, the whole thing inside is 289. So I highly recommend figuring out what the argument or the inside of the square root is. The proper term is argument.
Yes.
The number you're taking the square root of is called the argument. So figure out what the argument is, and then do the square root. Mr. Lewis is correct. It's 17.
Right. It just limits to less calculator mistakes. If you plug it all in at once, if you forget a parenthesis or something else, or you forget a squared, you can get the wrong answer, and then you don't know where you came from. But if you work it step by step, you can limit that mistake.
You got it. This one has two negative coordinates in it, but
does.
you know, just be careful. Keep the negatives in there. Don't forget about them.
It's true. So we want a square root of, this would be 1 minus negative 4, a lot of parentheses, plus negative 5 minus 6 squared.
You forgot the squared on the first one.
Oh, I did. See? You can even make mistakes when you're not copying it down.
And we get d equals square root of 146. So I follow my own advice. And to be honest, you could sometimes we could simplify it, but sometimes we might just find a decimal. So for today, we'll just find a decimal.
Ah, making it easy.
It's about 12.1.
You mean all those videos you made me do where we had to simplify square roots?
We'll do anything. Your mom's very proud of you.
Uh-huh.
All right. So, wow, this is our last slide. We have a triangle, and this is going to come up a little bit later. We're going to do some several things with this. But right now we have the coordinates of the vertices of the triangle. So, a triangle has vertices at A, B, and C.
Well,
And we're going to find the perimeter
yeah, so we have A, B, C.
with no picture, no diagram, just the coordinates of the points.
Right. So sometimes it might help to draw a picture just to
Yeah.
see what's going on,
Always.
but
Yeah.
not necessary.
But that's always helpful.
Okay.
So we're going to use the distance formula. To
Right.
find the length of the sides. To find the perimeter, we just add it up. And like I said, decimals happen.
6 minus 1 squared plus 8 minus 4 squared.
It's going to be the square root of 41, which is just about 6.4.
I don't know why I changed this to A.
Yeah, D for distance.
Still be D. Okay, what? 6.4?
Yeah, about 6.4.
Done.
Okay, let's find BC.
BC. Square root of BC, sorry. 11 minus 6 squared plus 20 minus 8. Oh, this will be a nicer one.
Yeah, it's square root of 169,
I got ahead of myself.
which is 13.
13.
So that side's a whole number, which is kind of nice. And then A and C, the last pair.
Okay, A and C. So we have 11 minus 4. Oh, I'm sorry, minus 1 squared
Excuse me.
plus 20 minus 4 squared.
That ends up being 356.
356.
And if we take the square root of that, about 18.9.
18.9.
Now, like I said, we could have left them all square roots and simplified, but this is fine. So we can approximate the perimeter. It'd be 6.4 plus 13 plus 18.9. We get 38.3.
Okay.
Now, just to preview a little bit what's coming up, was this a scaling triangle, an isosceles triangle, or an equilateral triangle?
I would say it's scalene
How'd you know that?
because none of the sides are the same as each other. If they were equilateral, all the sides would be the same. And if it was isosceles, 2 of the sides would be the same.
Very good. So it's coming up. We can tell whether it's a right triangle or not just from the coordinates, using slopes. And using distances, we can tell what kind of a triangle it is. Scaling, isosceles, or equilateral.
Right.
All right. Time for the journal assignment.
All right. I love journals.
Oh, yeah. Journals are great. All right. So just one problem, 4 parts. Kind of like what we were just doing. Find the length of the 3 sides of the triangle. Approximate it, the square roots with a decimal. And tell us the perimeter.
All right. I think sounds like a pretty easy thing to me.
Yeah, they can do it.
All right.
See you next time.